All right, in 5.5 part 2, we are going to look at graphing tangent and cotangent. So these, if you remember, are related to sine and cosine. Tangent is equal to sine over cosine, and cotangent is equal to cosine over sine. Okay, we've kind of mentioned those identities already, but we haven't worked with them a lot. We will work with them a lot more in the next chapter. But for now, we're going to use them to graph tangent and cotangent. So I have a list of angles here around the unit circle and then their corresponding sine and cosine values. Now, I have some negative angles listed here, okay, and it's probably not obvious yet why I would list those, okay, but just uh, before we talk about why, okay, remember a negative angle just means I'm going clockwise around the unit circle. So starting here, an angle of negative pi over 6 would be right here. Okay, so this angle here, negative pi over 6 would be the same point as 11 pi over 6. Okay, and then negative pi over 4, negative pi over 3, negative pi over 2. Okay, so that's what those negative angles, that's what those negative angles look like, okay? So let's start calculating a few values of tangent, okay? We know that tangent is equal to the sine over the cosine, so at negative pi over 2, we would just have negative 1 over 0, and whenever we have a 0 in the denominator, that means that the graph is undefined. Now, in terms of our graph, what that means is we will actually have an asymptote there, right? So at negative pi over 2, we will have an asymptote for tangent, okay? And I'll explain why in a minute. I am using negative angles, okay? For negative pi over 3, and if we do sine, so negative square root of 3 over 2 over 1/2. Well, remember, dividing fractions is the same as multiplying by the reciprocal. So this would be negative square root of 3 over 2 times 2 over 1. The 2's would cancel, and I would just get negative square root of 3 over 1, or negative square root of 3. Okay? So I'm not going to go through all of the calculations. Okay? So I'm just going to show you the rest of the table here for tangent. Now, we are going to stop at pi over 2. The reason that we are choosing values in between negative pi over 2 and pi over 2 is because that is one full period of tangent, okay? Once I go to my next point past pi over 2, this pattern is just going to repeat, okay, as long as I'm choosing values around the unit circle, okay? Even if I chose a value in between, and if I went that same distance from pi over 2, and it would have the same value. So go ahead and, if you want, pause the video, copy these values down, okay? But if I were to graph these, okay, with the angle as my x value and the tangent as my y value, this is what that one period would look like, okay? We have asymptotes at negative pi over 2 and positive pi over 2, and then here are those other 7 points that we just calculated, okay? So go ahead and jot this graph down on your paper as well. Now, tangent is also periodic, and we just mentioned that this would actually just keep repeating itself, okay? So this is one period. The tangent function would actually continue in both directions with this same pattern, right? It would look the exact same from pi over 2 to 3 pi over 2 as it does negative pi over 2 to pi over 2, okay? So the period for tangent, okay, remember period is the length of one cycle or the distance from the beginning of a cycle to the end of a cycle. So the distance from negative pi over 2 to positive pi over 2, well, that's a distance of pi, right? Same thing here. The distance from pi over 2 to 3 pi over 2, that is a distance of pi, okay? Now, I'm going to make a note, okay, that the normal period that we're going to look at goes from negative pi over 2 to pi over 2. And that's going to be important when we start looking at graphing shifts of tangent, okay? The domain, whenever we're including a bunch of asymptotes like this, it's kind of tricky to write the domain in mathematical notation. So we are going to say, I'm just going to write it out as all real numbers except, now we've got pi over 2, 3 pi over 2, 5 pi over 2, and then negative values of that as well. So one way that we can write that is except pi over 2 plus pi n, okay, where n is any integer, right? So if I add some multiple of pi or subtract some multiple of pi from pi over 2, I would get every single asymptote, okay? So that's one way to describe the domain of this function. The range then is easy, right? Even if we just look at one period, the range is going to hit every y value. So the range is negative infinity to positive infinity, okay? We can do something similar with cotangent, okay? Now, for cotangent, we are actually going to start at 0 and go up to pi. So if I look at 0, remember cotangent is cosine over sine. So this would be 1 over 0, which would be undefined, right? We can, continue that process just like we did over here. I'm not going to write all these out, okay? I'm just going to show you the filled in table here, okay? Now, going from 0 to pi, okay, if I graph all of these points, we should end up with something that looks like this, okay? From 0 to pi, right? That's going to be one full period of the cotangent curve. Now notice this one slopes down as we look at it from left to right, okay? So these are some important characteristics to think about as we're comparing tangent and cotangent. So, okay, remember looking back at tangent here. This one slopes up from left to right and goes from negative pi over 2 to pi over 2. Cotangent slopes down as we look at it from left to right and goes from 0 to pi. Okay, so again, this would continue to repeat itself in both directions. The period, we still say the period is pi, right? The period is just the distance from the start to the end. But let's make a note, okay, that goes from 0 to pi for our normal period, right? If we just take this one period. The domain, similar to tangent, we can say it's everything except where the asymptotes are. So we can say all real numbers except, and this is just multiples of pi, right? So I can say except pi times n, okay? And in the math world, it's usually assumed that n is an integer, okay? So the range then, again, this is easy. The range is just negative infinity to positive infinity, all right? So now let's take a look at graphing some shifts of tangent and cotangent. Let's start with tangent. So I've got the steps listed out on the back here. Now, most of the time, we're only going to be dealing with B and C shifts for tangent, okay? It's usually kind of difficult to sketch an A shift because all that would do is change the steepness of the tangent curve, and sometimes that's difficult to see. Sometimes there will be a D shift, okay, where we would just shift the midline. Okay, so in our first example, that's the first step, right? Find the midline. There is no midline, okay? So, or I'm sorry, there is a midline. That would be at just the x-axis. So let's get some axes on here. Okay, so I could sketch my midline at the x-axis, but we don't have to if there is no shift. So now, these next two steps are similar to when we graphed sine, cosine, secant, and cosecant, except now for tangent, I'm setting my starting point equal to negative pi over 2 and my ending point equal to positive pi over 2. Okay, so this is the big difference. Remembering that sine, cosine, secant, and cosecant all go from 0 to 2 pi, but tangent is going to go from negative pi over 2 to pi over 2, and then cotangent, which we'll look at in a second, is going to go from 0 to pi. Okay, so that's the biggest difference that we have to remember here. So for my starting value, I'm going to set 1/2 times x minus pi over 4 equal to negative pi over 2. Multiply both sides by 2. X minus pi over 4 equals negative pi. Add pi over 4, and we'll have negative 3 pi over 4. And then my end, 1/2 times x minus pi over 4. We'll set that equal to positive pi over 2. Multiply both sides by 2. And add pi over 4, and we'll get positive 5 pi over 4. Okay, so we actually only need 3 key values when we're graphing tangents. Okay, we need my starting, my ending, and then one point that's exactly halfway in between. Okay, so again, to find that point halfway in between, all I need to do is take the average. So negative 3 pi over 4 plus 5 pi over 4 would be 2 pi over 4. Divided by 2 would be 2 pi over 8, or 1 pi over 4. Okay, so these are my 3 key values. Okay, so I can go and say this is negative 3 pi over 4, pi over 4, and then 5 pi over 4. Now, the key then is my first and second, or I'm sorry, my first and last of the key points are the asymptotes. So let's sketch in some dotted lines here for my asymptotes. And then we just want to sketch the shape of the tangent curve. Okay, so now remember, tangent starts down here, crosses the midline at that middle point, and then comes up like this. So there are fewer points that I will be grading when you're graphing tangent, right? I'm really only looking at your 3 points here. And then if there is a D value, I would be looking for that labeled value as well, okay? Let's try another tangent example. Okay, so on this one, we do have a midline, okay? So we do need to make sure to sketch that. So let me get my axes in here, and then we can sketch our midline. Okay, so I'm shifting the whole graph up 1, so my midline is going to be at 1 right here. So let's go ahead and sketch that. Now let's set bx minus c equal to negative pi over 2. So 2 times x plus pi over 8 equals negative pi over 2. Divide both sides by 2, and we'll get negative pi over 4. Subtract pi over 8. So this would be negative 2 pi over 8 minus 1 pi over 8 would be negative 3 pi over 8. And then I guess I should have labeled that as start. Then my ending point for one period would be 2 times x plus pi over 8 equals positive pi over 2. Divide both sides by 2. And subtract pi over 8. So 2 pi over 8 minus 1 pi over 8 would be 1 pi over 8. So I'm going from negative 3 pi over 8 to positive 1 pi over 8. Halfway in between there, if we take the average, should be negative 1 pi over 8. So those are my key points. So we can go negative 3 pi over 8, negative pi over 8, and positive pi over 8. Sketch in your asymptotes. And sketch the basic shape. Now, the one thing that we would need to be careful of here is that tangent will cross the midline at negative pi over 8. Okay? So we need to make sure that we're showing it crossing the midline, not the x-axis in this case, because we had a shift up 1. Okay? So those are the points that I would grade you on. Now, one thing I did forget to mention on both of these was I could ask you to tell me what the period is. Okay? So for the other 4 graphs that we've looked at, the period was just 2 pi divided by b. For tangent and cotangent, the period is going to be pi divided by b. Okay? So my b value here is 1/2. So pi divided by 1/2 would be pi times 2 over 1, or 2 pi. And we can see that that distance from negative 3 pi over 4 to 5 pi over 4 is 2 pi. Similarly here, the period would be pi divided by b. Well, that would just be pi divided by 2. So the period is pi over 2. And that is the distance from my starting point to my ending point. Okay? Graphing cotangent is very similar. Okay? It's actually, in fact, the exact same steps, except I'll step my starting point equal to 0 and my ending point equal to pi. Right? So that's really the key for remembering how to graph tangent and cotangent. Okay? For tangent, we're going from negative pi over 2 to pi over 2. And for cotangent, we're going from 0 to pi. So let's run through a few examples here. So my starting point, I'm going to set 1/2 times x minus pi over 4 equal to 0, multiply by 2, and add the pi over 4 over. We'll get x equals pi over 4. Then my ending, I'm going to set this equal to pi. Multiply both sides by 2. Add pi over 4. And so this would be 8 pi over 4 plus 1 pi over 4 would be 9 pi over 4. So those are where my asymptotes would be. Then this graph will cross the midline, halfway in between. So that will be, if I take the average of these, 5 pi over 4. So those are the values that I need to label. So this graph is going to be entirely to the right of the y-axis. So I will put that kind of on the left side here. I'm not shifting up or down, so this graph is going to cross the x-axis at the midline. Right? So let's label our key points. Pi over 4, 5 pi over 4, and 9 pi over 4. I'm going to sketch in my asymptotes. And then remember the basic shape of cotangent is sloping down as we look at it from left to right. So here would be what this graph looks like, okay, including all the key pieces of information. All right, let's do one more example. So on this one, we do have a d value. We're going to be shifting down 1. Okay, so then again, we just need to take 2 times x plus pi over 8, set that equal to 0, and 2 times x plus pi over 8 and set that equal to pi. So divide by 2, subtract pi over 8, divide by 2, subtract pi over 8. So pi over 2, if I convert that to eighths, would be 4 pi over 8 minus 1 pi over 8 would be 3 pi over 8. So those are my starting and ending values. Those are my asymptotes. To find where this period will cross the midline, find the average. That's going to be pi over 8. So I can sketch in my axes. That will occur at, let's see, we're shifting just a little bit to the left. So let's, make that a solid line. And we're shifting down 1. So put this axis up a little bit. Let's sketch the midline in at -1. And let's label. So we're going from negative pi over 8, pi over 8, and 3 pi over 8. Sketch in my asymptotes. And sketch the basic shape of my curve. So remember, we'll be crossing the midline at pi over 8, not the axis. Okay? So we should have something that looks like this for one period of cotangent. And again, remember, this would just repeat itself. So if you were ever asked to graph 2 periods of one of these functions, we would just do the same thing. We would say 3 pi over 8 is my starting point. I'm going to go a distance of, in this case, my period is pi over 2, and then find the point right in between. Okay? So that is it for this video. The final question is going to pop up asking you what questions you have.